Alright, so let's see here. So when the absolute integer of this is positive or negative, then it will always be a positive. That's pretty obvious. And powers of the recipes. A to the power of m multiplied by a to the power of n equals a to the power of n plus n. An example would be 5 to the power of 3 by 5 to the power of 7 would be 5 to the power of 10 because if you take 5, 3, or 7, then it would be 5, 3 plus 7. Same thing with divide, it's basically like minus. So you say 5 to the power of 7 divided by 5 to the power of 4 would be 5 to the power of 3, which that would mean that's 5 to the power of 7 minus 4. A multiplied by b to the power of m would equal to a to the power of m multiplied by a to the power of n. So basically you're going to split it into two prime numbers. So when you have a number like 10 to the power of 7, then you split into two numbers, into 5 multiplied by 2 to the power of 7, and then you make each of those its own integer. So it would be 5 to the power of 7 multiplied by 2 to the power of 7. And a over b to the power of m would be a to the power of m, b to the power of m. So same thing here. So basically, if an entire fraction is powered, then each of those numbers would be powered. And then a to the power of m to the power of n is a to the power of m multiplied by n. So for example, if you take like a number, let's say 2, and then you add it on like to the power of 3 to the power of 4, then it would be 2 to the power of 3 multiplied by 4, which would be 12. Oh, and then if so, then yeah, that makes sense. But however, you always have to do what's in it first, and then you can calculate the outside. Calculating both these would just make it into an overly insane number. Let's see here. A multiplied by b plus equals to a multiplied by c would be a multiplied by b plus or minus c. That makes sense, of course, because if you're trying to have one integer and another, so let's say 1 by 2 plus 1 by 3, then it will be just like 1 multiplied by 2 plus 3, because it would essentially be the same thing. Because if you merge those two numbers, it will be 2 plus 3, and then if you do the other result, and it will be 1 multiplied by 2 plus 3, which will be 5, so the same result happens. But however, this is necessary because school education system. And the same thing for opposites. Actually, it's because of integers. So if a divided by b plus or minus c divided by b, then it will be a plus or minus c divided by b. So again, the same thing. 1 plus 3 divided by 2, which would be 4 divided by 2 equals 2. And if you do the other result, it would do the same thing. And if you try to do, well, a divided by b divided by c, and follow the same rules as the multiplication, then you will be completely wrong. Next up is, let's see here. Partial integers of trying to solving A, B, C stuff. That can all be skipped because of the 2 by A, 2 by C, 2 by C, etc. Oh, these ones. Interest rates. Hooray, my favorite. So, the interest rate for 1 month would be the interest rate for 1 month. The money rate for 1 month would be the debt for 1 month multiplied by 100 divided by interest. Same thing for a year, so those two don't really do different. Now here's the BS part. Money compounds per month. Basically taking money per month by a year and dividing it into each month of the day, so that would be 12. And then trying to find the amount of money given to you, or whatever the heck it's term called, would be the money multiplied by the interest rate, so that is nothing special. This is money we're talking about here. All these are XPCs, they're free, yeah, sure. So X3 was 2, and this 1, 2, 2, 1, 3, 4, yeah, sure. So let's see here. So x a y will be c, so it would be so it would be 3x 5y would be the same as x over 5 equals y over 3 because of the ABC rule, and x over y equals 5 over 3. Then would be yes, x over 5 equals 5 over 3. So if two the unknown integers hold the same spots, or if two integers multiply with the two already given numbers, then it would be first integer number multiplied by the second number, and then the second mystery number multiplied by first integer, which is complicated as hell, but I can see why. And then after that you have to negate every single one, as in like x or 4, until you negate everything and you find the results. If pairs of magic numbers same, then get rid of them. C2, let's see here. 1 divided by 1 over 2 equals 2 multiplied by 2 over 1 equals 2x. So a divided by b would be written as a over b, because a fraction is the same as dividing something. Numerator divided by denominator, obviously. So if so, then you can find that 2x would be 1.5, because x multiplied by 1 would be 2x, and if you find x divided by 1.5, which is technically x over 1 over 2, which is complicated but makes sense, and then if you apply that recipe for every single other integer, you found your result. So, and same thing over here. Here, it's the same thing. Now, here's the part where it gets freaking fun. Oh, so next part. Finding x. The first one, a, would be exactly the same as you think if you remember all the recipes from grade 3. B is a bit more complicated because it involves absolute values, which, well, if you tied it to basically every single other number, you have to calculate everything before the absolute value of an integer, and then the absolute integer of those two numbers that are calculated in between would be equal to the number outside of the absolute value. And then after that, you split up into two. Of course, this is dependent on if it's a single number or a fraction. If it's a single number, then turn the number into a positive and also a negative. And if it's a fraction, turn the numerator into a positive and a negative. After that, calculate all you want. C. This one is a bit complicated, but it's understandable. You're basically trying to cross over two numbers to be the same. So, example up here, 2x over 9 equals 16 over 5. Then cross over the two numbers. 2x multiplied by 5 equals 16 over 9. 2x multiplied by 5 would be 10 multiplied by x, which would be 10x, and 16 multiplied by 9 would be 144. And if so, then divide x, then you have 10x equals 144. So divide that by 10 because you're trying to find x here. So take 144 divided by 10, and if it doesn't come out as an absolute value, just write it down as a fraction. Example 2, same thing here, except that now there are two integers that cross over each other. So basically what you do here is that take each number multiplied by together, or here x minus 1 over 2 equals 8 over x minus 1. So basically x minus 1 multiplied by x minus 1 equals 2 over 8. And since because a number multiplied by another number basically means that number squared, make x minus 1 squared, and then make 16, then 8 multiplied by 2 is 16, so x minus 1 over 2 would be 16, and then after that find the square root of that number. So the square root of 16 would be 4, and then after that x, you would found x minus 1 is 4, and then after that if the integer is an even number, you can split it off into two, either positive or negative, because either way it does not really matter. But however, if it doesn't, then just go for the one way, because trying to calculate a negative integer is completely wrong. So after that find whatever's left in the recipe and done. Example 3, same thing over here except for the 2 powers, which would basically mean that the number, one number, or possibly 2, now is squared or cubed or whatever comes after cubed. And so then, well, just do the same thing. Multiplication numbers, if you take a cube, multiply that by, and that number would be x minus whatever, where multiplied by x minus whatever, multiplied by x minus whatever, equals 2 of the same negatives multiplied by each other. And after that, you find the cube root of that number, and then, here's the thing, if the integer is an odd number, then just calculate it. You don't need to split it off into 2. And finally, D. This one is insanely confusing because I don't know how this works. So what you basically have to do is that it gives you this problem. X minus 1 to the power of 2 will be the same as x minus 1 to the power of 3. So theoretically, if you say that, then theoretically the result will always be 0. So basically, if we say like x minus 1 here, then, well, obviously it cannot be 0, because if you take 0 minus 1 to the power of 2 multiplied by x by negative 1 to the power of 3, then you would just theoretically just made minus 1 minus minus 1, which would be 0. So 0 does work in this situation, but not always. Integral 1, relatively obvious. And now here comes the tricky part. If you take out x minus 1 and make it x minus whatever, then the number would always be resulting as in a 0, 0, a 0, the number itself, and that number itself plus 1. So basically what you have to do here is that take that number, and then, so basically you have 3 integers. 0, that number that has been negating the number, the mystery integer, and then the number itself plus 1, which would result in 0, obviously. And then you just split it off, then it would be x minus 1 to the power of 2 minus x minus 1 to the power of 2 multiplied by x minus 1, which would basically be, if we're going by the integral 1 here, then it would be 0 to the power of 2 minus 0 to the power of 2 multiplied by 0, which would still be 0. Of course, theoretically, then that would be minus 1 minus minus 1 multiplied by minus 1, and fortunately 0 multiplied by minus 1 does not do anything, so it works, yay. And this is confusing because I don't know how this works. And then after that, it would be x minus 1 to the power of 2 multiplied by, in square brackets, 1 minus x minus 1 in round brackets, which would be the same as 0. That, I do not know what step is that. And then after that, you have to go through x minus 1 squared will be 0, or 1 minus x minus 1 equals 0, and the x minus 1 is in square round brackets. And then you would find out x over there. Because, you know, if you take x minus 1 to the power, so if you say negative 1x or x minus 1 multiplied by x minus 1 would be 0, then theoretically the number would be 0, itself, and itself plus 1. So choose either of those 3 numbers. Oh boy!